Okay, here's the first page of the Unit 5 assignment key. First question here, a rectangle has a perimeter of 40 centimeters. Write an equation which relates the length of the rectangle as a function of the width. So we're looking for something that says L equals something and there's a W in there. So we know we're dealing with perimeter. Perimeter is you add up all the sides, length and length and width and width. There's two lengths and two widths to get one perimeter for a rectangle. We want the length to be equal to something, so we want to solve for L. So let's take this 2W and throw it over to that side. Perimeter minus 2 widths is equal to 2 lengths. At this point here, I'm almost solved for L, but I'll need to find a way to get L by itself. 2 L's, it's easy to just divide by 2 on both sides. At this point, I've got length is equal to perimeter minus 2 widths over 2. This tells me the actual value of my perimeter, which is 40. So if I take 40 minus 2 widths over 2, both of these 40 and 2 are divisible by 2. So I could say 40 by 2 is 20, and 2 by 2 is 1. So the length is equal to 20 minus the width, which is going to be option A. So this phrase here relates the length as a function of the width. That means that L is equal to something and there's a W on the other side. Here they give us a graph for our second question. It says determine the range of the graph. Range is the Y values that are permissible for the graph. So we're not concerned with how far side to side. We're concerned with how far up and down. So this graph has a lowest point, and that lowest point is there at 3. So this graph gets as low as 3 and goes up. On this graph here, the last points that are listed are at 11. It looks like it might continue going upwards, but all we can see now is the spots at 11. So somewhere between 11 and 3 are the values of Y we could expect to see for this graph. So when we're looking at this thing, the range is not going to be the X values at all. So it can't be C or D. For A tells us that our Y values are anywhere between -3, which is way down there somewhere, and 1, which is there. So the graph would be in this space. That's not right. So A doesn't work. B has to work. Hope it's B. It says between 3 and 11. So Y values can be greater than 3, or the Y values can be less than 11. And that looks like it's true. It's at least the closest to true. So the permissible Y values here are between 3 and 11, and they're all real numbers. Another way we could have knocked out A from contention is A tells us only natural numbers, but we can see that there is a line connecting these points which goes through all of the fractional or decimal divisions in between there. So it can't be natural numbers either. So that's got to be B. Do a couple more here because that was already a quick question. This looks like the same graph as the last one, but it's asking us instead for the domain. So last time was range and this time domain, and domain will be the X values. So for the X values of this graph, how far left and how far right? The furthest right that we see is right there, and the furthest left that we see is right there. So these values, if we just go down the graph here to see where they hit, the furthest left, the smallest number, the greatest negative number, is -3, and the highest positive number that we see here is 1. So we want X values anywhere between -3 and 1 are allowed, and other ones aren't. So like last time, if it's asking about domain, who cares about the Y values? We're looking at X values, and the X values are anywhere between -3 and +1. And they are real values. Both of those say real, that's okay. So it looks like C. D says anywhere between 3 and 11. 3 is about here, and 11 is way over there. The graph would be not showing up if we looked in that area. So for this question, we choose C. The x values, the domain, are anywhere between -3 and +1 in this graph. Question 4, determine the value of the x-intercept of the function fx equals 5x minus 5. So an x-intercept happens when the y value is 0. So you cross, let's use this as an example, you cross the x-axis when you go down, 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 your y values reach 0. So the y values are these guys. So if I write this as 0 equals 5x minus 5, then I can solve for x. So I'll take this 5 and I'll move it over. I'll say 5 is equal to 5x. I can divide both sides by 5. Cancel, 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 cancel. And 5 divided by 5 is 1. 5x divided by 5 is just x. So here, the x-intercept of this graph, 5x minus 5, would be at 1. Another way to do this, if we wanted, would be to factor 5x minus 5. It is a polynomial. So if we take 5x minus 5, we could say that that's 5 times x minus 1. So if I say my y is equal to 5 times x minus 1, and I know my y should be 0, then I can say, well, if I've got this, I want to solve for x. I'm going to divide both sides by 5. Cancel, cancel. Anything divided, or 0 divided by anything is still 0. 0 equals x minus 1. And if I want x, I'll take that 1 and throw it over there. So positive 1. It was negative over this side. When moved over here, it becomes positive. Equals x. So if we do it by factoring, we get the same result. Or if we do it by solving algebraically, we get the same result. Choose your preferred method. Question 5. Determine the value of the y-intercept. So that's when x is equal to 0 on your graph. The x values are here. When the x values are 0, that's where you're in line with the y-intercept, with the y-axis. So of the function, same function, 5x minus 5. So in this case, my y value, my fx value, or in this case I'd write y value, has to be something I'm looking for. And 5x minus 5 becomes 5 times 0 minus 5. Anything times 0 is 0. So it crosses the y-axis at -5. I'm going to stop this video and start a new one for the next.